And you can be sure that there are many carbon compounds out there because carbon is one of the most abundantly found elements on Earth. And in our syllabus, we are going to talk about a group of carbon compounds known as hydrocarbon. What is hydrocarbon? Hydrocarbon means a compound that contains two types of elements. The elements can either be hydrogen or carbon. And the example of hydrocarbon that we are focusing on will be alkane. Alkane is a saturated hydrocarbon. Now, what is saturated hydrocarbon? Saturated hydrocarbon means a carbon compound that is already saturated, or in simple English, we call it full. Let's take a look at one carbon. In Form 4, do you remember which group does carbon belong to? Carbon belongs to group 14 in the periodic table. And since it belongs to group 14, how many valence electrons does one carbon have? Each carbon have 4 valence electrons. 4 valence electrons, is it enough to make the carbon stable? No, right? Because you already learned in order to become a stable atom or ion, they need to have 8 electrons in its outermost shell. And since carbon have only 4 valence electrons, it can form 4 more bonds with either another hydrogen or a carbon. So let's say this carbon forms bond with hydrogen. How many hydrogen atoms can be bonded to the same carbon? The answer is 4, right? So the formula will be C1H4, or we can just write it as CH4. What if I have 2 carbon? The carbon on the left can have 3 more bonds. The carbon on the right also can have 3 more bonds. If they decide to bond with hydrogen, how many hydrogen can bond to these 2 carbons? The answer is 1, 2, 3, 4, 5, 6. So the formula is C2H6. If you see me writing alphabets and numbers, they are known as molecular formula. But if you see me drawing the structure of the alphabet and the amount of it, we call this as the structural formula. So again, if you see alphabet and numbers, they are called molecular formula. If you see the structure of the compound, they are known as structural formula. Or you can take this as the skeleton of the formula, meaning the structure of the formula. Another way to understand it easier is you imagine carbon is a house and they have 4 chairs in the house. If this carbon wants to throw a party, how many friends can this carbon invite? They can invite 4 other friends. And let's say this carbon decides to invite hydrogen to come over for the party. This carbon can invite how many hydrogen? Yes, it can invite 4 hydrogen. What if hydrogen number 5 wants to join the party? Can hydrogen number 5 join the party? No, sorry. Why? Because the house is full. That means the compound is already saturated. Other hydrogen cannot come in to form a bond. That's why alkane is considered as a saturated hydrocarbon. The same case for C2H6. These 2 carbon has bond to 6 other hydrogen. What if hydrogen number 7 wants to come for the party? Can hydrogen number 7 join the party? No, right? Because this compound is already full. But please take note that we cannot write full hydrocarbon in our exam. So we use the word saturated hydrocarbon. To make a long story short, what if I want to know how many hydrogen can be bonded to 10 carbon down the road? I obviously is not going to spend time here drawing 10 carbon and then draw like God knows how many hydrogen, right? So to make the long story short, we use general formula. The general formula for hydrocarbon is CnH2n plus 2. So for each carbon, they actually can be bonded to twice the amount of carbon amount plus 2 more extra. For example, we have C1. H will be 2 times 1 plus 2, which is equivalent to C1, H, 2 plus 2, 4. Okay, and how about our second example here? If I got C2, H can be 2 times 2 plus 6, which give me an answer of C2, H, 4, 4, 4, oops, sorry, this is not plus 6, this is plus 2, right? So it's 2 times 2, 4, 4 plus 2, 6. So it makes our understanding much easier. What if I am talking about a carbon compound which is C5? Then how many hydrogen will it be bonded to? I will use the formula, right? Cn, H2 times n plus 2. So for a carbon compound with 5 carbon, it can be bonded to 2 times 5, 10, 10 plus 2, 12 hydrogen. What if I have C10? H will be how much? So 2 times 10 plus 2. So if I have C10, H will be 22. Okay, so this is how we calculate the formula for the compound. And besides formula, we also need to talk about the names of the different amount of carbon in the alkene family. In order to know the name, we must first know the prefix of each amount. If there is 1 carbon, we use meth. If there's 2 carbon, we use at. If there's 3 carbon, prop. 4 built. 5 spent, as like in pentagon. 6 hex. 7, take a guess, hat. 8 is oc. 9 is non. 10 is deck. Let me repeat. If there's 1 carbon, we call it meth. 2 is called at. 3 prop. 4 built, not but, yeah, it's built. 5 pent. 6 hex. 7 hep. 8 oc. 9 non. 10 deck. And because they belong to alkane family, it will end with A and E at the back. So to name this compound CH4, since they have 1 carbon, I am gonna call it methane. And how about this C2H6? They have 2 carbon and they're saturated and they belong to alkane family. So I would call it ethane. How about C5H12? Let's look at 5. It's met, at, prop, built, pent. And it belongs to saturated hydrocarbon known as alkane, right? So I end it with A and E. So C5H12 is pentane. And how about C10? H22. 10 is met, at, prop, built, pent, hex, hep, oc, non, deck. Take a wild guess. What's the name for an alkane with 10 carbon? Yes, it is decane. Alright, so before I move on, let's do a mini conclusion on what we have covered so far. What is hydrocarbon again? Hydrocarbon is a compound that contains hydrogen and carbon. And a group of hydrocarbon that we are studying for your syllabus is alkane. What is alkane? It's a saturated hydrocarbon. Saturated in simple English means full. That means the carbon bond is already full, and each carbon can bond to 4 other elements. It could either be hydrogen or another carbon. So if there is one carbon, it can bond to 4 other hydrogen. And can hydrogen number 5 join in the party? No, right? Because this is already saturated. And if you show the structure, it's known as structural formula. If I write out the amount and also the type of elements present, it is known as molecular formula. And how do I remember the rest of the family? I use a general formula. And the general formula for alkane is CnH2n plus 1. How do I name the alkane? Well, I must first know how many carbon are in the compound. If there's 1, I use meth, 2 is add, 3 prop, 4 built, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec. And because they belong to alkane family, I will end the prefix with A and E. So prop will become propane, bute will become butane, and so on. Okay? Now, after we have cleared this, let's take a look at the physical properties of this family. What are the physical properties of alkane? In terms of melting and boiling point, generally they have low melting and boiling point. The reason being that they are non-metal. Carbon is a non-metal, hydrogen is a non-metal, so it forms covalent bond. And covalent bond always have a weaker bond, right? So the melting and boiling point for this family is low. However, if you go down the group, as the amount of carbon and hydrogen increases, the melting and boiling point will also increase when they go down the group. How about physical state? Because of its low melting and boiling point, the first 4 carbon exist as gas, meaning methane, ethane, propane, butane exist as gas, then followed by liquid and followed by solid as they go down the group. Because as they go down the group, they have more members. When they have more members, the van der Waals force in the covalent bond increases. When the van der Waals force in the covalent bond increases, it takes more energy to break the bond. And because it takes more energy to break the bond, the melting and boiling point will increase as they go down the group, and because it gets harder and harder for them to break the bond, right? And another way of putting it is they become closer as well. So the physical state will also change from gas to liquid to solid. For the same reason that they get closer together, they will become denser as they go down the group. So do they like water? Is this family soluble in water? No, they are not soluble in water because they are covalent bond, and usually covalent compound, they are not soluble in water, but they are soluble in organic solvent. And does this family conduct electricity? The answer is no. It's not a conductor because they do not have free moving ions. And why don't they have free moving ions? The reason is because they are covalent compound. Covalent compounds are neutral, and so they do not have any ions that are able to move in order to conduct electricity.